What I have here is a 3-wire control or a motor starter circuit. Simple motor starter circuit, nothing fancy. There's an emergency stop button, there's a stop button, there's a start button. Selector switch is not used. All my buttons are connecting directly to the terminal strip, which makes it easier for troubleshooting. You may or may not have terminal strips. It might be a direct connection. Now, the power coming into this motor starter's 3-phase power is roughly going to be 208 volt 3-phase, but I dialed the frequency back to 0.5 hertz. And because of safety standards in an open equipment like this, I'm using roughly 24 volts, 50 volts. Keep things safe. Now, the contactor itself, you have the motor starter contactor right here, which is just nothing more than a large relay. On the side of the relay is going to be an auxiliary contact. This is going to be 2 contacts. You have a normally closed on the top and a normally open on the bottom. And that contact operates when the motor starter starts, so it's just an extra contact. This unit on the bottom is going to be your overload module. Inside this overload are bimetallic strips. 3 separate bimetallic strips that connect through the power circuit. As electrical current flows through the circuit, electrical current creates heat. And if the bimetallic strips get hot, they tend to bend. And when they bend, they're going to activate a trip mechanism which operates contacts. Right here we have a normally closed contact and a normally open contact. Both of these contacts are controlled by the bimetallic strip. This little dial adjusts the current, or interpret this to the amount of bend. The bimetallic strip bends a little bit or it bends a lot. That's what the dial is, to dial in the amount of bend. Now, once I go ahead and hit the start button on this circuit, the contactor pulls in, the contacts change state, and right here I'm showing right there rotation, which would be in a motor. So right now the current is actually traveling clockwise. The emergency stop button will kill the circuit. Start the circuit. The stop button kills the circuit. Start the circuit. And also what will kill the circuit is the overloads. So if I push the overload trip button, if the overloads get too hot, the bimetallic strips bend and trip the overloads. The reset button resets it. Now we look on the drawing for this. Start-stop station schematic is actually very simple. It doesn't look near anything like the real world. You're looking at a logical drawing, not a bunch of wire. But here we have the power coming through, down right here through the power circuit, through the stop button, up to the start button. We push the start button down, that sends power to the load. Once the load energizes, the latch and holding contact closes, allowing you to let go of the button right there to actually latch the circuit on. So marked in red is the power. Logical sequence of operation. If I push the stop button, it breaks the circuit. Power flows up to the start button, flows to the holding contact. I push the start button down, that sends power to the motor starter, the load. Once this load energizes, the holding contact latches. We let go of the button, the circuit is latched on. This is a safety circuit. This is going to require, anytime the load stops, to push the start button to restart it. If we replaced everything here with a selector switch, if the overload's ever tripped, when the overload's reset, everything would start up instantly, which could be very dangerous. Now, to de-energize this circuit, I push the stop button. Once the stop button's pushed, it interrupts the circuit, it dumps the load, de-energizes the load, unlatches the contact. If the overloads were to trip, that too will interrupt the circuit, opening the holding contact, shutting the circuit down. So the circuit itself isn't that complicated. It's a 3-wire control or a simple start-stop station.